Let's take a few minutes and look at our practice questions about significance tests for means. So the first test involves construction zones. Is there evidence that the average speed of drivers in a particular construction zone is greater than the posted limit? So the null hypothesis would be that the average speed of drivers is really what is posted, which is 25. If we're interested in people speeding, then the alternative that we care about is a mean speed that's greater than 25. So for randomness, the question says that we took a random sample of 10 cars. And for independence, 10 times 10 is 100, and it's reasonable to believe the 10% rule is met here. It's reasonable that the number of cars that go through this construction zone would be 100 or more. So notice for normality, 10 is a very small sample size. It's well less than 30, so the central limit theorem doesn't just necessarily apply. But if you look at the given dot plot, the speeds don't have outliers, and they don't show any skewness in either direction. There are no outliers, there's no serious skewness, so it is reasonable to still use an approximately normal sampling distribution for the sample mean. And again, the idea is we're going to calculate a sample mean, and we're going to use that sample mean in order to create our test statistic and our p-value. So this test name, this is a test regarding a population mean, so this has to be a t-test, and we're using only one sample of data, a random sample of size 10. So this is a one sample t-test. So the test statistic, and again, I would encourage you to calculate the test statistic on your graphing calculator. The test statistic comes out to be 3.05-ish. So because there are 10 observations in this data set, the degrees of freedom are 9. Again, using your graphing calculator then, the p-value is 0.007. The conclusion that we would get with this p-value, which is well less than 5%, this is an unlikely outcome, so we do reject the null hypothesis. So there is sufficient evidence to suggest that the mean speed of drivers through this construction zone really is greater than 25 miles per hour. So we have rejected the null hypothesis, believing that, in fact, the alternative may be true. We think we have evidence that the alternative is true. Well, that leads us to part B. So given what we've done in part A, what kind of an error could have been made? Remember, a type 1 error occurs when you reject when you shouldn't. A type 2 is you don't reject when you should. That's the quickest way that I can state those. So we did reject the null hypothesis in type A. So a type 1 error is what's possible here. So what would this mean? How would I interpret this? Well, if I've rejected the null hypothesis, then what that means is I believe we have evidence of the alternative. So I believe that we have evidence that people are speeding through this construction zone, but in fact, I'm wrong. People really aren't speeding on average. So we believe there's evidence that the mean speed is greater than 25, but we're wrong. There's no reason to believe that drivers are speeding. So what might a consequence of this be? Well, if I think people are speeding, then maybe there will be a bigger police presence here. Maybe I'll monitor this construction zone more carefully. But the truth is, if I'm wrong, if people really aren't speeding, there's no reason to be doing that. I'm basically wasting those resources where those police officers could be better used elsewhere. So again, if we think drivers are speeding, we may send more police officers to patrol this area. But given that drivers aren't really speeding on average, it means those police officers really aren't needed, and they would be better serving the public by patrolling somewhere else. So what's important about errors? First of all, you basically need to know the definition. So a type 1 error is when you reject, but you shouldn't. You're wrong. It's an error. A type 2 error is when you haven't rejected. Well, but you're wrong. You should have. So what's a little more challenging then is to interpret what those different errors mean. That's why I thought this question was particularly important. So question number 88. let's state the hypotheses here. So this is a test where we're looking at how well people recall words when they're listening to music versus when they're just studying in silence. So this is a paired t-test because we are looking at pairs of observations from each subject. And when we are doing a paired style test, the mean that you're going to be looking at is the average difference. So that's why I've written this as mu difference. This is the mean difference in the number of words recalled when listening to music versus when working in silence. If you wanted to call this a one sample t-test, you're not wrong because you're working with one sample of differences. I just want you to recognize that term paired t-test. That means we're looking at a pair of observations from each subject. So if there's nothing special going on, if they're basically able to recall the same number of words, whether they're listening to music or working in silence, I would expect the true average difference to be 0. What we're looking for here, the way this question is phrased, we're looking for evidence of the following. We're looking for evidence that, in fact, when listening to music, they're able to recall fewer words. So if they recall fewer words when listening to music and more words when they're working in silence, that number of words is larger, so this difference would be negative. That's why we're looking for evidence of a mean difference that's less than 0. That would suggest they're recalling more words in silence than when they're listening to music. So there are 30 subjects here, so the degrees of freedom is 29. I know that that's a very simple calculation to do. It's something that you should document whenever you are doing a significance test for a mean. Remember, significance tests for proportions don't have degrees of freedom. This is only for significance tests for means. So they gave you the p-value. So what does a p-value mean? It's important to remember this definition. The p-value is the probability of a sample mean as or more extreme than what we have observed. As or more extreme means in the direction of the alternative hypothesis, but under the assumption that the null hypothesis is true. So given that the true mean difference is 0, so assuming that the real mean difference is 0, the likelihood of a sample mean difference as low or lower, so as small or smaller than what we have observed, is only 0.0027. So this is a very small p-value. So this conclusion, you should always compare your p-value to your level of significance. In this case, that's 5%. So we can reject the null hypothesis. This is an unlikely event. So we do reject the null hypothesis. So that means that we do have evidence of the alternative. And I would just copy the words. We have evidence that the true mean difference in the number of words recalled when listening to music versus silence, so music minus silence, is negative. So in other words, what does that mean? It means that music may inhibit the ability of the students to recall words in this particular context. So more about error types. A type 1 error. A type 1 error would mean we have rejected when we shouldn't. Well, describe what a type 1 error would mean in this context. Rejecting means that we believe we have evidence of the alternative. So we could simply say we believe that we have evidence that music will inhibit students' ability to recall words. But in fact, it doesn't. We're wrong. It's an error. So a type 2 error means we haven't rejected when we should. So if we haven't rejected the null hypothesis, then in a type 2 error, we don't believe that we have evidence of the alternative. So notice then we would say we don't have evidence. We don't believe we have evidence that music will inhibit students' ability to recall words. But we're wrong. In fact, it does. So we don't believe that music inhibits students' ability to recall words when it really does. So those are probably the shortest descriptions you could give for what, in this context, a type 1 error or a type 2 error would mean. Now, which is possible? Well, because in part C, we rejected the null hypothesis, so a type 1 error is what's possible here. So type 1 means we've rejected the null hypothesis when we shouldn't. So the last part of this question, actually it's question number 90, but it's related to the previous question. So what would give you higher power to detect a mean difference as extreme as -1? So a level of significance of 1% or a level of significance of 10%. So remember, power is that you are rejecting the null hypothesis when you should. A type 2 error is when you fail to reject when you should. You've made an error. Power is that you are rejecting when you should. So power can be increased by increasing two things. We could increase the sample size, but that's not an alternative that's being given here. The other thing that we could do is increase alpha. So the simplest way to remember power is increased by doing two things. Power goes up when you either increase the sample size or you increase the level of significance alpha. So in this case, to answer the question then, more power would be achieved by raising the level of significance. We used a level of significance. More power would be achieved by using a level of significance of 10%. So when you raise the level of significance, you're making it easier to reject the null hypothesis. What that means is that p-values of like 6, 7, 8, 9%, even those p-values will now be rejected because alpha has been raised to 10%. Well, if you are making it easier to reject, power means you're rejecting when you should. So if you are doing something that makes it easier to reject the null hypothesis, that means you are increasing the power of your test against this particular alternative. Power is rising.